In this lecture we're going to cover this concept of precipitation calculations. So if we had a solution of lead 2 nitrate and a separate solution of sodium chloride. So if we put these in water in their own separate beakers, and let's see, we make a 0.05 molar solution of lead 2 nitrate and a 0.050 molar solution of sodium chloride. So the point is they totally dissolve. Lead 2 nitrate and sodium chloride totally dissolve under these conditions. So you would get lead 2 ions and 2 nitrate anions floating around in water for every single lead 2 nitrate that dissolves, and you would have sodium chloride ionized, and for every single sodium chloride that dissolves you would have an Na plus cation and a Cl minus anion floating around in solution. So now we're going to take these two solutions, we're going to mix them together. In water. So now you have lead 2 plus, 2 nitrates, and sodium and chloride. And so of course if you dissolve just a little bit of lead 2 nitrate and sodium chloride, you have tons and tons of lead, sodium chlorides and nitrates floating around in solution. So to keep this part balanced for what we're fixing to do, so let's just say there were 2 sodium chlorides dissolved, for example. So now you mix the two solutions together, so what can happen is you can form new chemical compounds. So the lead and the chloride could get together, for example. So you could take and you can make lead 2 chloride, or sodium and nitrate could combine to make sodium nitrate solid. So the question is, once you mix these two together, is lead 2 chloride sufficiently soluble in solution that it would stay dissolved? And is sodium nitrate sufficiently soluble in water under these conditions that it would stay dissolved? And the answer for the sodium nitrate is yes, sodium nitrate's very water soluble, so it stays dissolved. But lead chloride is not very soluble in water. Right, so as soon as the lead and chloride find each other, they're going to combine to make solid sodium chloride. Well, that's what we want to determine. Under these conditions, would lead 2 chloride precipitate out of solution or not? So to determine that, we are going to calculate what's known as the reaction quotient and answer the question, will PbCO2 precipitate from the solution or not? Okay, so to calculate the reaction quotient, it's just like the solubility product constant. So for this reaction it would be concentration of lead 2 ions times concentration of Cl minus ions squared. Sorry, let's go back to the beginning. I need to make a change. This was supposed to be 0.1 molar. That's what I have in my notes, so we'll go back and change that back so the math is going to be what I have in my notes. Okay, so since lead 2 nitrate totally dissolved in solution, so every lead 2 nitrate gives one of these. So if we added enough lead 2 nitrate to water to make a 0.05 molar solution, then we'd have 0.050 molar lead 2 nitrate in solution. And of course, since there's twice as many nitrates per lead, the concentration of the nitrate would be 0.1 molar, but that doesn't matter because we're concerned about the solubility of lead chloride in this reaction because the nitrate's going to stay dissolved anyway. And so every single sodium chloride that dissolves gives 1 sodium and 1 chloride. So if we add enough sodium chloride to water to make a 0.1 molar solution of sodium chloride, then the concentration of sodium would be 0.1 molar and chloride would be 0.1 molar as well. So in this solution then, the concentration of lead is, once we mix them together, is 0.05, and the concentrations of chloride is 0.10 molar. So if we plug those values into this calculation, so 0.05 times 0.1 squared gives you 0.0005, and then what you have to know is KSP. So KSP for, so this would have to be given to you for lead 2 chloride is 1.6 times 10 to the minus 5. So now compare QC that you calculated versus KSP. Right? If QC is less than KSP, then no precipitate forms. If there was any solid lead chloride, more would dissolve. If QC equals KSP, then that means you're at equilibrium. And when you mix the two solutions together, nothing would happen. If QC is greater than KSP, then precipitation will occur. And so in this case, QC that we calculated is 0.0005, which is greater than KSP, which is 1.6 times 10 to the minus 5. So PbCl2 will precipitate. So if you did this experiment in lab, if you made a 0.05 molar solution of lead 2 nitrate and a 0.1 molar solution of sodium chloride and mix them together, then what you would find is that lead chloride would start to precipitate out of solution. So the minute you mix them together, the solution would become very cloudy, and gradually the lead chloride that's formed would settle out to the bottom of the reaction. Okay, so let's take one more example. So if we had barium chloride, so let's say we took 50 mils of 0.0010 molar plus sodium sulfate, 50 mils of 0.0010 molar, and mix them together, then that's going to form barium sulfate plus 2 sodium chloride. So will a precipitate form? And if so, what would the precipitate be? Well, in this case, the sodium chloride is extremely soluble in water, so that's not the one that's going to precipitate, but barium sulfate is not very soluble in water, so that's the one. Basically, I would ask you, is barium sulfate going to precipitate from this solution or not? So you'd have to know KSP for barium sulfate, which is equal to 1.1 times 10 to the minus 10, so very small number, right? So it's not very soluble in water. So when you mix the two together, is the barium chloride and sodium sulfate sufficiently concentrated that you're going to get a precipitated barium sulfate or not? Okay, so what we need to do now, so basically it's the same problem as last time. You were just giving different information to start with. So what we need to figure out first, so we have these two solutions of barium chloride, which is totally dissolved, and sodium sulfate, which is totally dissolved in water, and then we're going to mix them together. Sodium chloride is going to stay dissolved in water, so nothing's going to happen to the sodium chloride. The question is, will the barium sulfate chemically combine to form a precipitate or not? So we need to calculate new concentrations when we mix these things together. Okay, so for the barium, if you start with 0.0010 mole per liter, and you have 50 mils, which is 0.05 liter, then you have 0.000050 mole of barium 2 plus, and for the SO4 2 minus, sorry, I think I gave you wrong numbers again. This is supposed to be 0.00010 molar. And 50 mils of that, so 0.05 liters. Okay, so that's how many moles of barium are in this flask, and that's how many moles of sulfate are in this flask. And then the new molarity, so new concentration of barium, will equal the 0.000050 moles over the new volume. Since they're both 50 mils, so the new volume is now okay. So take the moles of sulfate in the new flask divided by the new volume. So it's 5 times 10 to the minus 5 molar. And now calculate QC. So 5 times 10 to the minus 4 molar for barium, and 5 times 10 to the minus 5 molar for sulfate. So QC is equal to 2.5 times 10 to the minus 8, and then compare QC to KSP. So in this case, QC, 2.5 times 10 to the minus 8, is greater than KSP, which we said was 1.1 times 10 to the minus 10. So BaSO4 will precipitate. Okay.